In oligopolistic industries, oligopolies may have an incentive to cooperate. And in many cases, this is illegal. Firms are not often allowed to cooperate or collude with each other. But firms that do cooperate are called a cartel. Probably the most famous cartel in the world is the OPEC cartel, which is a consortium of oil-producing and exporting countries that collude, not in violation of international law, but they're very open about their collusion with each other. The reason why firms may have an incentive to cooperate is because they may find it to their benefit to do things to keep prices high for everyone, to voluntarily restrict the amount of output they put into the market so that everybody can charge a higher price higher up along the market demand curve. Now, one of the interesting things about this, however, is once firms start to cooperate, it's often in the interest of one firm to cheat on the agreement. While the collective profits of a firm may be higher if they can get everyone to agree, it may be in their own individual interest to cheat on the agreement that they come up with. Here's an example. Consider a pair of firms, two firms, a duopoly in this case, that face the market demand curve given by the first two columns of the table on the right. So the price and quantity are the market demand curves. We're going to make a couple of simple assumptions. One is that each firm has zero fixed costs and that they can produce units at a marginal cost of $10, and this $10 is constant. So they can essentially produce produce as many units as they want at a cost of $10 a piece, and we can forget about fixed costs. If you think about this, remember the competitive outcome was to produce up until price equals marginal cost. In this case, when price is equal to 10, the market demand is 120 units. So in a competitive world, the market would produce 120 units and charge a price of P equals $10. A monopolist, on the other hand, would want to restrict the amount of output that they sell, and they set marginal revenue equal to marginal cost when Q is equal to 60 and P is equal to 40. You can see in the column on the far right that the monopolist's profit would be $1,800 at this level of output if they produce Q equals 60 and charge $40 per unit. So the monopolist wants to produce 1,800 units. Now suppose instead, though, that this was an oligopolistic industry somewhere between competition and monopoly. We're going to consider the duopoly case. A duopoly is an oligopolistic industry with exactly two firms. Now, if the two firms could collude, if the two firms could combine, the highest profits available to them would be the $1,800 profit that the monopolist could earn. So if each of the firms would agree to produce half of the 60 units, that is, each firm produces 30, there would be 60 units put onto the market, and firms would charge, consumers would pay up to $40 for each of these units. Profits in this case are equal to $1,800. Each firm gets $900, and this is the best combined total that our duopolists can obtain. But here's the interesting part. Each firm has an incentive to cheat on the agreement. Suppose that the two firms get together and they agree to each put 30 units into production, and that would keep the market price at $40. Consider instead what happens if one of the firms decides to cheat and not produce 30 but produce 50. If this is the case, then there are 80 total units being produced, 30 by the honest cartel participant and 50 by the cheater. And we can look and see the profits of the cheater in this case. The cheater produces 50. The market price now has fallen to $30 because there are 80 units available. And this leaves the cheater with $1,500 in revenue minus $500 in costs, or $1,000 in profits. So the cheater is better off by cheating. Consider the other firm. The other firm has produces the 30 that they promised, but now they get to only charge $30 a piece because the market has been flooded with 80 total units. So total profits fall. The cheater gets $1,000. The other firm gets $600. So we're down from $1,800 to $1,600 in total. But the cheater goes from $900 to $1,000, so the cheater's profits have risen. We can see then that in this particular instance, it's beneficial for one firm to want to cheat on the cartel. Suppose instead that each firm decided to produce 40 units. At 40 units, we have an equilibrium. At 40 units, we can show this, and we'll explain this in the slides to come in a little bit more detail. But if each firm produces 40 units, the combined profits are $1,600 Each firm is earning $800 of those profits. And one of the things that you can show is that neither firm has an incentive to cheat in this case. So the equilibrium here, and we'll explain what we mean by that going forward, the equilibrium here for a duopolistic industry actually works out to be 40 units per firm for 80 units total, a market price of $30, and combined profits of $1,600 or $800 per firm. And you can see that this is somewhere in between the monopoly outcome and the competitive outcome. And as the number of firms gets larger, as we move from 2 firms to 3 firms to 4 firms, this equilibrium condition will move closer to the perfectly competitive condition. We'll move from monopoly toward perfect competition on our spectrum of industrial organization.